unfortunately, I can't be there in person. I came down with the flu last weekend. I'm still recovering, so apologies if my voice sounds a little rough, but I'll be able to make it through it. Through this. Also, it's always a little challenging to present remotely. I like to, get feedback from the room, play off the room. I can't do that. I can't see you folks, but that's all right. And probably best if we hold questions to the end, so I can just, focus on getting through this presentation. All right. I'm Karl Newell. I'm a network software architect at Internet2. I got recruited by Adair, who's on the program committee, to talk about Cisco NSO. She had been in a couple of nanogs. There had been a lot of mention of NSO as a tool, a lot of like some folks were using, but not a lot of content on NSO itself and why folks would choose to use it. But I'm not going to just focus on NSO for this talk. I'll talk about some of the other tools we use for automating our network, and give an overview of that. Get my bearings here. So I'll give a background of Internet2, some history on our automation efforts, with a focus on our migration when we upgraded our network a couple years ago, what we're currently doing with software and automation, and lastly, keys to success. And hint, it's not about technology. It was a lot about our processes. So Internet2 runs a nationwide network for research and education. We have fiber. We run an optical system, a Sienna open line system with wave server transponders. On top of that, we're mostly running a Cisco 8200 packet network, but we also have some Arista boxes. We still have some legacy Juniper QFX boxes in some locations. And we also actually run a out-of-band management network on Juniper gear. Our main focus is to connect to regional networks, which are typically state-run networks, and then they connect down to research and education. Initially we started connecting, tier 1 or R1 research or universities, but now we're seeing a lot of connectivity through K through 12, state and local government, and libraries. This is just an overview of numbers of what Internet2 does. We have higher ed members, we have industry members. If you've heard of In Common and Shibboleth, we're a steward for that. We're a steward for Eduroam in the US, and so we help get that deployed across the country. So the history of our automation efforts. So now I still think it was yesterday, but it's now been, I think, about 6 years since we started. But we embarked on this effort to upgrade our nationwide network. At that time, we dubbed it next generation infrastructure. So right around 2020, early 2020, right when the pandemic started, is when we sort of started settling down on hardware. And then we ended up deploying not one, but two, or upgrading two nationwide networks at the height of the pandemic. We upgraded our Sienna system at that time, upgrading it to FlexGrid and open line systems, and again, replacing it with wave server transponders. And we deployed our Cisco packet gear in parallel to our existing Juniper gear, and then did our migrations. And again, all this at the height of the pandemic. We are also doubling our device count because we were going from chassis-based systems to discrete 1U boxes. We were changing vendors. We had a lot of history and experience with Junipers, and we were going to a whole new vendor, and we were trying to migrate our legacy configuration. And so because of all those changes, doubling the device count and changing vendors and migrating legacy configuration, we also decided that part of NGI, besides resetting the economics and changing our platform, to reduce our costs, software and automation were going to be a big part of how we're going to do that. One, for just managing the network, and eventually what you'll see later on is that enables us to offer automated services to our members. And that's kind of where our current focus is. So the solution at that time, we didn't have a solution at the time. We actually went out to some of our partners and kind of, we had a proof of concept where we, asked them to propose some software solutions to what we wanted to do. And we had a couple of our participants, and Cisco came back with one where they showed us NSO. We were a little skeptical at first. I was a network engineer at the time. I had played with Cisco NSO a little bit, and I installed it and I loaded it up and opened a folder, and suddenly there were um, half a dozen folders, lots of files, and there was Yang and XML and Python, and I was really overwhelmed. And I was like, there's no way we can use this. But a Cisco SE flew out to Tucson, where I live. We spent 2 days and we put together a proof of concept, and I really saw the power of NSO. At that time, we were spending efforts on automate our network, at least in a test environment with Ansible. We also use Salt. So we had experience automating networks with other tools, but we started to see the value of NSO when we saw it in action, because NSO is built to automate networks, and that's what its focus is. So we eventually chose Cisco NSO. I mean, it was also easier because we're at that time, or when we finally purchased a new network, we were purchasing Cisco gear, so it made getting NSO. It made a lot more sense to get NSO at the time. But we also still use a lot of Python. We use a library, or during the migrations, use a library called PyATS, which I'll cover a little bit. I'll spend some time talking about Google Sheets and app scripts. Spreadsheets get a lot of flack, but they can definitely be useful, and you'll see why those are useful. And I was actually at a conference a couple of weeks ago where another organization had a lot of success, using Google Sheets and AppScript to help automation. And of course, we couldn't have done any of this without all of our network engineers and developers that were part of the project. All right, so why Cisco NSO, or what does it offer? And again, sorry, I don't know if I mentioned this. NSO stands for Network Service Orchestrator. Its primary focus is configuration orchestration. It is multi-vendor, and the nice thing about it is it's a centralized view of all the devices on your network. There is one. It's essentially a database, but there's one device tree that contains all of your devices and all the configuration for those devices in one central location. It provides system-wide transactions, meaning it treats the entire network, all of your devices, essentially as a database. So if you're pushing out configuration to multiple devices, you're pushing out an L3 VPN configuration that touches 5 devices. If one of them fails, by default, NSO will roll all those changes back. So you're not worrying about you've done some automation, you've pushed out some change, and it didn't work in one place, and you have to figure out where it didn't work and how to get that one piece into compliance. NSO sort of helps you take care of that. It's really good with dealing with out-of-band changes. That's always a problem with a lot of systems. That if the device isn't what the central system, the device config isn't what the central system thinks it should be, there can be difficulty in managing that. So Cisco NSO handles that pretty well. And we actually use that to our advantage. And the primary one for us, and this was huge, a primary factor in deciding on an NSO, was the command line interface. So we were going from a system where we had almost no automation, at least from the engineer's perspective, other than the tools they might have used themselves. Some of our engineers, were using Jinja templates to for interface or BGP configuration, but that was all bespoke and that was all per engineer. We were trying to get them to adopt the system, and I'd seen efforts, even at Internet2, where we try to put an automation system in place, using Ansible and Git, and it was kind of overwhelming. It wasn't something they were used to. But with NSO, they can log into the system, and it's the CLI that they're used to, and you can actually change the flavors. So it has Cisco syntax and Juniper syntax. So engineers were immediately comfortable with using something like NSO, and it's really just one way. It's just a centralized place to see all your configuration. But then the real power of it comes in how it works, which is service models, and the power of NSO is built around Yang and netconf and XML. I mean, the folks that wrote the standards for Yang and netconf are also some of the same people that wrote the original software that was TLF before Cisco acquired it. I didn't get to see Rob's talk the other day. I'm looking forward to watching it. While Yang gets a lot of flack in the community, I mean, it is what it is. It is the tool we have for modeling. And we'll look at what a service model looks like in a little bit. But the idea is you write your service models in Yang, and your service models, these are typically vendor neutral. And they're really defining what the inputs that you then use to configure your service. So, I always use L3 VPNs as an example. So even something super simple, or a very simple L3 VPN, what do you need? You need your nodes, your endpoints, you need some IP addresses, maybe a route target. So that's what your engineers focus on. Those are the variables to configure all this. They don't have to worry about all the configuration that gets pushed out to the devices. We're handling it on the back end. The developers are working with the network engineers to determine what configuration gets pushed out. And that's where the templates come in. So templates are written in XML. Again, this is just legacy coming from netconf. But don't worry, you don't actually have to, write any XML from scratch. It's really a lot of copying and pasting, and then figuring out where your variables are, and and inserting variables into the XML templates. NSO is declarative. It determines the minimal amount of change needed to configure the device. It also tracks any configuration changes it makes as part of a service, service model, and reverts those changes when deleting the service. So you don't have to write a separate workflow to remove service configuration, which is something I've run into in the past using other tools where I had to write something to put config on and another workflow to take the config off. NSO keeps track of all of that, and that's another huge advantage for us. All right. All right, so this is an example service model. This is what you would see on the NSO CLI. For us, this is essentially a customer BGP peering service. But this is the data that an engineer has to think about. If they're using if they're going into NSO to configure it. We'll talk a little bit later about how we can just move up the stack here, and we can have a web interface on this. We can have our members directly configuring this. Which we'll show, because anything you have in NSO automatically gets exposed northbound via various APIs like netconf or RESTconf API. But an engineer is going in and they're configuring the pieces that are they need to think about. What's your VLAN ID? What are your IP addresses? What are your neighbors? And all of this is constructs we've sort of developed. Like you see this thing here called a PDP. That's actually just an interface abstraction. And then we have various ways to, select prefix lists that we will, allow from those neighbors. But this is all an engineer has to configure, and something like this, when they go deploy it, this could result in, hundreds or even thousands of lines of config on multiple devices in the network. And again, this can be multiple devices inside one service configuration. So again, it's not, I don't think about, I have to go to device A to configure a service and then device B to configure a service. I go to NSO and I just configure a service. NSO takes care of configuring the devices appropriately. Also, this is just kind of a recap what we talked about. On the top layer, you have the service model. That's where, we're sort of defining our API into the services in our network. Then you have the device model, which, then NSO is taking the service model and instantiating device configuration. And it does that through network element drivers, which are, you essentially have a NED for each kind of device type on your network. And that can talk via netconf, and you can talk via CLI, and it doesn't even have to be network devices. There's supports for hundreds of different devices. All right, so why do we choose NSO? Again, it's vendor agnostic. We currently use it with Cisco IOS XR, Arista, and Juniper EX and SRX devices. It's a declarative configuration. And again, as I mentioned, when you delete a service, it removes all the related configuration. We don't have to concern ourselves with that. It provides system-wide commits. So, problems don't strand broken configuration. Primarily, engineers aren't copying around their version of a configuration template. So, what we saw on our old network is, every engineer had their own version of the template they used, or they probably got it from somebody at one point, but then, it evolved over time. So various, pieces of the same kind of configures, like a BGP peer, might have slightly different, configurations, because they've, evolved separately. And engineers spend less time implementing changes. They're not thinking about multiple devices and all the configuration on those devices. They go to NSO, and it deals with, pushing out the config across the network. So I'm going to talk, just kind of highlight some of, how we were successful using, again, not just NSO, but the other toolings, our migration. And that, this was in, oh man, I can't remember anymore. 2021, we had our new Cisco gear in place in parallel to our Juniper gear, and we had to migrate, all of our BGP peers over to our devices. And that's a whole other talk about how we, wired these up, configured them. But the highlight here is, we had about 2,000 peerings to migrate in about 30 days. And so, the tools that we had of it, the tools that we spent a lot of time, about 18 months at that point, getting ready, is what really helped us to succeed in this migration. So we use our NSO services. We defined BGP peers that we needed to migrate, and part of that migration was, standardizing our configuration and our service models. Again, because in our legacy network, there was a lot of snowflakes. That's, a lot. You can't really have those snowflakes, when you have an automated network and when you have consistent configuration. And I'll cover this in more detail later. We essentially imported our legacy peers, our legacy BGP peerings from the network configuration and from a custom database into a Google Sheet, produced output that we can then use to configure NSO. Again, we had 2,000 peerings in 30 days, and at the end, we were doing about 150 a night. And the last night, we did those 150 in about 15 minutes with almost, no issues to note. We use Cisco PyATS. I'll cover that a little bit more later. That was to validate the routes received from prior to migration and after migration, and see if there were any changes in our route policy. We also use the robot framework, and this is for unit testing on our NSO models. So most of our models have some robot frameworks tested, built for them. This is, this is testing the input to the model, or the any kind of input validation that we have. Like if you have a VLAN range restriction, we run robot tests to make sure that NSO is doing the right thing. That you can't configure a VLAN range or VLAN that doesn't make sense, or you can't configure IP addresses that don't work. All right, so this is going back into the the whole Google Sheets concept here. So this was essentially an extract, transform, and load. So we had our legacy configuration from our MX network. We also had some custom DB information that we had to pull in to provide information to the Cisco models, because part of our NSO models, we're starting to add metadata to the models just so we can track them, like what member the service was for, or any other kind of data related to that, or like circuit IDs and service IDs. We're actually putting that data into NSO, because then it can actually push that down into our network, into interface and BGP peer descriptions. But we wanted a checkpoint, because we didn't want to just assume, we weren't going to assume our software or automation was going to pull all this data out, do the right thing, and then just push it directly into NSO. We wanted a checkpoint, and so we figured, something like a spreadsheet would make a lot of sense. An engineer could look at it. So we settled on Google Sheets. So at least then an engineer could pull all this data in, look at it, see is this valid, or maybe this is a BGP service that we don't even need to migrate. We can just delete that row. We don't migrate that service. We've cleaned up corrupt from our network, or it's missing some key pieces of information. So they can manually edit it. And then what one of our engineers did was then just leverage AppScript within Google Sheets to actually generate all of the NSO configuration needed to migrate that set of BGP peers. And so there was another tab in the spreadsheet that they would open up, and they would have all the NSO configuration they could copy and paste into NSO and prep that for a maintenance window. And this also generated all the configuration we needed for our validation scripts. And this was just ended up being a really good workflow because engineers had a checkpoint to fix the data, and then it provided all the configuration output they needed to migrate the service. The PyTS validation scripts, you basically wrote, we looked at the script would run on the Juniper network prior to migration, look at, routes and routes received or routes rejected. The nice thing about PyTS, one thing it can do is, it's really good at scraping operational commands and then saving that in, normalized format like JSON. And this is across devices, so it saves it in the same kind of format. So we would scrape the routes pre-migration off the Juniper network, migrate the BGP peer over the Cisco network, run a similar script against the Cisco, scrape that data, and then run a third script which would compare the results. And then we'd have a quick way to evaluate these are the routes we saw pre-migration, these are the routes we're seeing post-migration, and is there a difference? And this was really key to getting to helping with our migrations, because initially, again, this is an all new network, this is an all new way of writing route policy. We weren't going to get it right. In the initial few days, the first days of migrations, we only did a handful of migrations per night. And we spent a lot of time, figuring out where we got the route policy wrong. And this tool helped us greatly because we could quickly identify, these are routes we need to go look at, figure out what's going on with them, and why aren't we accepting them, or why are we accepting new routes that we shouldn't be. And so, that's what led us to the ability to, migrate 150 peers per night at the end, because we had written this tooling that helped us figure out, when we had issues with our configuration. So this is a lot of numbers, but the one I want to focus on is that bolded line, the 7.8 config compression ratio. It's a concept we sort of developed. And the idea is, this is old, some old data, but right now, if you log into our NSO and kind of look at all of our service models, there's about 32,000 lines of configuration. And even that, that wasn't all done manually by an engineer. A lot of that's automated by other tools, and actually some of the way NSO works sometimes. You can have an NSO service create another NSO service. But we have 32,000 lines of service configuration. That results in 250,000 lines of device config that gets pushed out to the network. So that's config compression. So that means engineers are 8 times less amount of configuration they're manually managing across the network. So we kind of use that as a value to say how what kind of time are we saving our engineers, or them not having to worry about all this configuration across the network. All right, so what are we doing nowadays? Now we've got we've migrated the network, we've got our new network up and running. Wish we could call it done, but we're not. We're going to keep working on new services. And so we learned a lot from building out all of the services we needed to support initially. And now we can do pretty rapid iteration with our engineering team. We actually developed a concept called a paper prototype, where we can just go into a Google Doc right now and sort of that example I showed you of a service model. We kind of outline all of that in a Google Doc first and put it in front of engineers and say, does this look right for this new service we're developing? Like we recently developed a layer 2 EVPN service at one of our exchange points. And that way an engineer can, sort of look at it and get a feel for it and say, yeah, this looks good, or we need these other values in there. We can do that all before we touch any code. And we can interact with the engineers and get feedback pretty quickly. When we do service development, we keep service options to a minimum. To me, I think that's key with automation. The reason you have config sprawl and you have snowflakes is because if you have access to all the knobs, maybe people, turn on all the knobs, and you don't want to, turn on all the knobs. That reduces your, configuration consistency. So our service models are the minimum, knobs available. Like if we don't need to change the MTU for an interface or a service related to an interface, but we don't allow you to set the MTU. That's hard coded in the configuration. This also reduces the amount of testing needed because every knob you have, you should be running tests for it. And so the less you have, the less tests you need to write. And we spend a lot of time defining what a service is. That's really important. That's the service is your business logic. What are you going to offer to your customers or to your members? So we spend a lot of time defining that. And the rest is, we have a lot of experience now turning a service around into, the Yang service model and the device configuration. That's, I'm not saying it's an insignificant amount of work, but we're experienced with that now. And so we can turn that around quickly. So we just really need to focus on defining what a service is. As I mentioned, we're using it multi-vendor. I forgot we also have some NCSs in our network, and this all works great across these. Even the Cisco devices, they works differently in different situations like NetFlow. So we just have to write that into our device templates, and handle things differently. But it all works pretty well. And so now a lot of our team's efforts, on the software development team is on user-facing service provisioning. We've already deployed this thing called the Internet2 Insight Console. Anybody here can go to it. It's console.internet2.edu. If you don't have a login, you can use the Looking Glass, which is a way to run select commands on any of our routers that is publicly available. That's actually support. Most of that is, the API to all this is fast API. The Looking Glass features are running Nornir on the back end with with Scraply as well. So besides the web interface, it's also got a full API. So you could script these commands. We've just released last October layer 2 and 3 circuit provisioning. This wasn't new for us. We are actually replacing a legacy tool called OESS, written by our partners at the Indiana University Global NOC years ago, or actually originally for our OpenFlow network. Hugely successful. It was just time to upgrade the software and the UI. So that's been completely rewritten. But this provides layer 2 and 3 circuit provisioning for our members, and a lot of that's for Cloud Connect. So we have Cloud Connect into all the major cloud providers: AWS, Azure, GCP, and Oracle. Now we're working on a project called Routing Intentions, or prefix management. So initially, what we want to show people is, what routes we're receiving from you, and what we're accepting, what we're rejecting, what the status of those routes are. Are they RPKI valid? What's their IRR status? So initially, at least show members what we're seeing from them. Then eventually, maybe move into some prefix management. The way our network works, for some members, we only accept certain prefixes, or ones that we've agreed to accept from them, so we can show them, and they can manage those prefixes as well. The future is maybe all member services. At least provide visualization, or show you all the services you have in our network. Some of the stuff is not available in the console. Like a lot of the BGP peerings with us right now. They're still configured by our network engineers. We at least want to show those, and eventually we like it so members can manage all of those services directly. And again, with the console, it's written API first, so anything that shows up in the console has an API for it. So eventually, users could write their own tools for provisioning services on our network. All right, getting close to the end here. Keys to success. This one's huge. I spent a lot of time talking to folks about this. Um, you know, when we started down this path, we made a fortuitous decision to sort of integrate our software development and network engineering teams. I mean, part of that was sort of forced because we didn't have a software development team. It was sort of born out of our, or butted off from our network engineering team. But we were tightly integrated. We met, we have official meeting on the calendar weekly. We still meet weekly. But during development of all these initial NSO service models, an engineer and the software developer might be meeting every day, or might be working hand in hand. And to me, this was the number one factor in our success. We didn't have a development team that went in, gathered some requirements, went off for 6 months, built something, then came back and it didn't meet the needs. And there's a lot of reasons it's not going to meet the needs because one, the users didn't define their needs properly, which is it's common, it's fine. But having just constantly communicating was really important to us, and that's why we're successful. And also, iteration. Um, the one thing I like to tell people is don't be afraid to start over. Especially when we started our NSO development, we didn't know, we didn't always understand NSO. We didn't understand its workings. We didn't understand the best way to do things. So we would make decisions, realize later that that was the bad decision. So instead of, holding on to something we spent a lot of time writing, we're okay with just, sometimes just throwing it away. Some service models on their third revision, and some have been completely, rewritten from scratch. And so again, this is just, software development, recommendation. Um, don't hold on to what you've written just because you spent some time on it. Always refine what you're doing. And especially as you learn more about the tools you're working with. And we're still learning more, and there's a lot of decisions we made that we know that there's better ways to do it. And if we have the time and resources, we'll go back and fix it. And finally, right tools for the job. I've been doing various kinds of IT work for 25 plus years. I'm a huge proponent of open source software. I've used it almost my entire career. And honestly, NSO might be the first time I've really advocated for buying a tool. That's because, it's the right tool. It's designed for network automation. It's not like other tools that, they're kind of cobbling network into that tool. And I think things are getting better. I mean, I'd love to spend more time seeing what Ansible and Salt can do nowadays. I know the tools and the libraries have gotten a lot better. NSO was built for network automation, and it saves us a lot of time and effort in what it can do. But again, it doesn't meet all of our needs, so we look elsewhere. As I mentioned, we're using PyATS library. We're also using Nornir and Scraply. Those tools are very effective for us. And finally, like I already said, spreadsheets work. Don't knock them. There's definitely a place for them. You can dive into the power of Google Apps Script. It's basically a JavaScript-like framework, but there's a lot it can offer you. And with that, I am done. Thanks a lot for your time. And again, apologies I couldn't be there in person.
Thank you, Karl. That was great. Being an Internet2 member myself, I did find this to be very interesting and informative about what you got going on. And I want to thank you again. Is there any questions from the audience? Okay. Well, thanks again, Karl. That was great.